Hello everybody, my name is Shay and today I'm going to talk about our work on Ultimate Benchmark for Container Image Scanning. It's a short preliminary work paper and this work has been done between myself, Jeffrey and Clan at BlackBerry Security Research Group. We're going to talk today about container image scanning. When you're using containers, you're probably using a base image that is publicly available on the internet. But here's the problem. If you have it, so do the attackers. The attacker can download a public image as easily as you can. And as the image is copied and used, which is the appeal of using container image, of course, the vulnerabilities in that image are replicated. And you need to make sure that the container you're using doesn't contain any known third-party vulnerabilities, or at least you need to have the visibility into those vulnerabilities. And that's where container image scanning comes in. What won't container image scanners do? They won't find new vulnerabilities, they won't find backdoors, and they won't find malicious containers. What will they do is find all known third-party vulnerabilities in your container. And there are a number of different products that do container image scanning, but the problem is they don't all give the same answer, which was a surprise to us when we first started looking at this topic. You can run 4 different scanners on the same image and you'll get 4 different results. How do we know this? Well, we tested them. None of the scanners we tested, in this case, we found the superset of the issues found by all other scanners. Okay, so none of them knows completely the big picture. None of the scanners reported all known to us vulnerabilities. And all the scanners we tested had some kind of false positives in the vulnerabilities they reported. And so we realized that we need the benchmark. We need some kind of ground zero truth first to dig deeper into those vulnerabilities and to understand what's going on there. How do we even approach the comparison of those scanners? But first, to do this, we need to understand the general architecture of the scanners. 3 phases mainly 3 phases: component detection, vulnerability matching, and reporting. Component detection is about detecting the software composition of the container image. Vulnerability matching is about given the list of the software composition, given the list of packages in the container image, scanner goes, takes the metadata of this image and matches this of the package and matches the packages against known vulnerabilities in various security feeds. And finally, reporting. And we're talking about the results difference, the difference in the results and inconsistencies. We need to understand where those may be coming from. First, the first phase, component detection. Some scanners, most traditional scanners, in fact, they excuse me, they employ the standard technique as they query the package manager to understand what software is in the container image. For example, the package query or in Ubuntu is, in the Debian in Ubuntu, or other package manager, depends on the distribution. And given that, however, other scanners, they can deploy binary analysis. For the second vulnerability matching stage, some scanners can have different composition of vulnerability fits. None of the scanner we saw use just one vulnerability fit. Some of them use commercial ones. In that makes the difference, of course. And finally, reporting. It's about ambiguity in reporting, in how they understand the parse security fit and how they understand the results. And this is probably the biggest part of the biggest issue in those source of the inconsistencies. And we'll talk about this more. So now, knowing this, we can kind of dig deeper and try to build the ground zero truth. And what we did, we took 5 most popular distributions: Fedora, Ubuntu, Debian, Alpine, CentOS. We ran a bunch of scanners, merged the results, deduplicated vulnerabilities, and took those vulnerabilities and manually judged them given the information and the security fits that are applicable to us. And we came up with the benchmark. During this process, what we saw I'm sorry, one word before on how we chose those images. So it was a game on the balance between stability and popularity. On one hand, we need stable container image that doesn't change, that the software composition stays stable. On the other hand, we don't want super old images that not being updated because they're old. We want still popular images. And that's how we came up with those three main distributions, Alpine, Debian, Ubuntu, and those specific versions as 10.2, Ubuntu 18.10, and Alpine 3.9.4. We ended up with 98 manually judged Debian vulns, 72 for Ubuntu, and 10 for Alpine. And you can see the number of CentOS vulns in Fedora is just humongous. And so given the time that we had, we couldn't manually judge them. And another problem with Fedora was that most of the scanners actually don't support Fedora. So what did we see during that manual judgment process? We saw that many vulnerabilities, yes, indeed, we can map them to true positives or false positive. In between true positives, we have two big groups are recently found vulnerabilities that just haven't been fixed yet, or triaged as unimportant. And those unimportant ones, they kind of linger there a long time, and that the distribution maintainers just don't want to fix them, or just because they are unimportant. For false positives, the main ones are backport patches. In this case, for example, the vulnerability that was patched in BusyBox in Alpine, scanner didn't detect this patch. Non-functional packages like license packages or empty packages. Kernel vulns, for example, of course, container image can't contain kernel libraries. In this case, SE Linux, however, scanner did report it, so that's false positive. Architecture mismatch, for example, ARM versus x86, where vulnerability is only applicable for ARM, for example. However, here's the question: what is if there is something in the middle, not true positives, not false positives? We call it inconclusive, and there are several of those groups. Let's start with inconclusive. So, for example, untriaged. This vulnerability updated based on June 2024. This specific vulnerability was untriaged in the Debian security feed, and sorry, in Ubuntu security feed. And of course, we don't know. It might be true positive, it might be false positive, depending on how the the maintainers of the distribution will triage it. Some vulnerabilities are environmental, depends on the build argument or usage pattern. Some vulnerabilities are invalidated by comments, for example, no security impact. So what does this mean? Or future unclear. Vulnerabilities marked in the comment not for us. Conceptual weakness in the PGP server design. So what does this mean? Does this mean it's not vulnerability? Well, it seems like vulnerability to me, but will this be fixed? I'm not sure. Another interesting class is what we marked version mismatch, where different feeds disagree on fixed or affected package versions. For example, in this case, vulnerability in GCC. According to NVD, it was fixed up to 8.8.0, and Debian does report 8.4 as vulnerable. And final group is D, disputed by maintainers. For example, the security researchers raised the vulnerability raised the bug as vulnerability, and the maintainers say, well, it's either not a security vulnerability, or I don't agree with it, or something like that. So what do we do? Whom do we trust here? And that's the problem here. We couldn't manually judge it. However, scanners are required to judge it on spot, and they have this binary decision whether to report it or not. And so sometimes they don't have other choice. They have to kind of mark it as unimportant or negligible. And then by doing this, they just move the burden of figuring this out, burden of analysis onto the customer. So the truth is, many times, even when having all vulnerability reports, scanners don't know whether vulnerability is applicable or not. And what we claim that this decision of how to treat those I, MM, and D, this decision is environmental. And that's what we did. We took traditional quality metrics such as precision, recall, and F measure, and we created the benchmark based on those manually judged vulnerabilities and the scanner results. And these these results are different based on the relaxed or paranoid mode. How do you map? What do you do with those intermediate vulnerabilities that can can be mapped, on the other hand, to true positive or can be to false positive. So because this is environmental decision, we say depends on the customer. If customer thinks that the most suitable mode for this customer is relaxed, where they'd rather map this to false positives, that they'd rather treat those inconclusive vulnerabilities as false positives, then they will look at the relaxed results. Or if the customer is paranoid, like, I don't know, Department of Defense, where they can throw bodies of security analysts into sifting through potential false positive, then they will treat all the inconclusive vulnerabilities as true positives. And as you can see, the performance of the scanners is different depending on the mode. And following this process, we develop some practical recommendations for the customers. So first, before choosing scanner, assess risk tolerance. Can you afford to miss vulnerabilities? Or must treat all vulnerabilities as potentially critical, paranoid mode? What base image are you using? Right? Is the image supported by the scanner or not? Because as you saw in the table, different distributions, scanner performs differently on different distributions, and not every scanner is best in all the distributions. Finally, based on risk number 1 and base image 2, use the benchmark results in the table to select the appropriate scanner. A couple more practical recommendations from our experience. No image had 0 vulnerabilities. A lack of vulnerabilities points to configuration problems or unsupported image, like with Fedora example. Combining multiple scanners in a CI/CD pipeline is a good idea. But first you need to decide how to merge those results, union or intersection. And intersection probably not a good idea. And finally, keep watching the benchmark for changes, because it will change as new vulnerabilities come up. And the word on registry embedded scanning, if you rely on container registry scanning, just remember that the container registry still use the scanners underneath, and they have the same advantages and disadvantages. So you need to be mindful about that. We open sourced the benchmark, so you can use it in 2 modes, SuperScan or Score. Go ahead, check it out, and read the README. I think it's written pretty well, so I hope you will use it. And send us a line if you have further questions. And I think that's the time for questions. Thank you for listening.